Hey everybody, hope you guys are doing well today. Today we get to look at the graphs of secant, cosecant, and cotangent, our reciprocal functions. So this should be a fun exploration to see what these are going to turn out to be. Let's start with the secant first. Now we know the secant is the reciprocal of 1 over the cosine of x. Now I always find this interesting to see what students would expect this graph to look like. Okay, so now no cheating, no graphing this on your computer, on your calculator. I want you to pause this video and sketch what you think the reciprocal of the cosine function would look like. What's going to happen if you flip each y value of the cosine? So pause the video now. All right, so I've got a graph ready to go. Putting 0, pi, 2 pi on. You know, with cosine, we have our 5 favorite points. Let's figure out 5 points on secant, and let's see what we've got. Now, let me put on, I'll make this 1. I'll make that -1. All right, so let's work our way around the unit circle. What is the cosine at 0? Well, we know the cosine at 0 is 1. So if we're going to graph the secant, we need to know what the reciprocal of 1 is. And the reciprocal of 1 is 1. Okay, got 1 point. All right, let's go to pi over 2. Okay, what is the cosine of pi over 2? That would be 0. So then we say, okay, what's the reciprocal of 0? How does that work? Well, let's see here. Let's think about how I can get 0. 0 could be thought of as 0 over 1, correct? 0 over 1, 0 divided by 1 is 0. So when we take the reciprocal of that and we flip it, we get 1 over 0, which is undefined. So at pi over 2, right here, our function is undefined. That's not a hole, that's going to be a vertical asymptote. All right, let's continue on. Pi, what is the cosine of pi? Cosine of pi is -1. What's the reciprocal of -1? -1. 3 pi over 2. We're back to the cosine being 0. Okay, and the reciprocal of 0 would be undefined. We have another vertical asymptote. And at 2 pi, the cosine of 2 pi is 1. The reciprocal of 1 is 1. Okay, so this is what we have so far. And I don't know if this is enough for us to be able to determine exactly what this graph looks like. We're going to have to do a little bit more thinking. What we could do is we could grab some additional points and just flip those fractions and work through that. That would involve using, taking the square roots, using decimals to approximate. Instead of doing that, let's just think through this. Okay, so we're at 1. Okay? And the cosine, as we go from, let's see here, probably going to capture part of my picture on this, that's okay. As we go from 0 to pi over 2, the cosine goes from 1 to 0. So this whole time, it's getting closer to 0. Now, what happens to the reciprocal of numbers as they get closer to 0? So we know the reciprocal of 1 is 1. Okay. Now, the reciprocal of 1/2, if I pick that one, which is an easy one, that's 2. Let's continue to get closer to 0. What's closer to 0 from 1/2? I don't know, 1/4. What's the reciprocal of 1/4? 4. What's closer to 0 yet? I don't know, 1/100th. What's the reciprocal of 1/100th? 100. How about 1/10,000th? The reciprocal of that is 10,000. So there we go. As the cosine goes to 0, what's happening to the secant? We have this vertical asymptote. It's actually heading up to infinity. All right, isn't that what, where did it go? There it is, lights. Okay. Isn't that what's happening with these values? So if this is what the cosine of theta is, this is what the secant of theta is, and that's going up to infinity. Now, what's going to happen when we're here? Well, now we're looking at, man, I'm getting lost on my pages. Here we go. We're looking at cosine going from 0, where the secant is undefined, to -1. And the reciprocal of -1 is -1. The reciprocal of 0 would be undefined. But right here, the cosine might be, I don't know, -1/10. And what's the reciprocal of -1/10? -10. Or if I was a little bit closer, if it was at -1,000th, right there, just a hair bit over, the reciprocal of that would be -1,000. So as you've probably already figured out, despite my attempt to explain that, we're going from -infinity up to -1. And then we're going to revert back down to -infinity. Now we are into the fourth quadrant. Okay, down here we're going from 3 pi over 2 to 2 pi. The cosine there is positive, so the secant has to be positive. Okay, and it's going to go from -infinity down to 1. We get a graph that looks like that, a really interesting looking graph, and it looks more interesting if we actually graph more than one period. So instead of doing that by hand, I'm just going to go to Desmos. There it is. Okay, and let's graph the secant of x. Okay. We graph from right here from 0 to pi over 2. But when we look at the bigger picture here, we just see that it's kind of this U shape. Careful, it's not a parabola. Sometimes students want to call these parabolas. They're not parabolas. They're not quadratics. Okay? They're just a U-shaped graph. And it's just these alternating U-shaped graphs as we just head down our number line. So, kind of a neat graph. It's really fun to look at when you also graph the cosine with it. Oops. There we go. And what do you notice? Okay. We notice they kind of touch, they come and meet each other at the maximum and minimum values of the cosine, and that makes sense. Because here the cosine is 1 and the reciprocal of 1 is 1. You know, we said that quite a bit here. Okay, cosine's -1, the reciprocal of -1 is -1, so they touch there. Now here as the cosine goes to 0, the secant goes to infinity. As the cosine starts here and comes to 0 that way, the secant's going to go to -infinity. So we get a neat looking graph. Let's write down some details here. There we go. What is the domain? What happened to my pen here? Okay. What happens to, what is the domain of our secant function? It is certainly not all real numbers, is it? Okay. What numbers are in the domain? Or we should maybe ask ourselves what numbers are not in the domain. Well, most of them are in the domain, right? Okay, it's kind of weird to use the word most when we're talking about infinitely number possibilities, but I think it's okay to say most of them. Our domain is going to be most of the real numbers. Just some of them aren't in there. Which ones aren't? Well, where do our vertical asymptotes happen? Well, the first one happens at pi over 2. The second one happens at 3 pi over 2. The next one would happen at 5 pi over 2. How do we write this? We've done this before. We start at pi over 2, and then we have a vertical asymptote every pi. And that makes sense because every pi, the cosine is equal to 0, and its reciprocal is undefined. So we're going to say except x equals pi over 2 plus pi k, where k is an element of the integers. How about its range? Now we know the range of cosine is -1 to 1 inclusive. How about the range of secant? Well, it's 1 inclusive up to infinity. It's -1 inclusive down to infinity and nothing in between. So we're going to write that as y is an element of -infinity to -1 inclusive union 1 inclusive to infinity. What is its period? Well, its period is still pi. It's still repeating itself every 2 pi. We're back here. The next part of our graph would be like this, which matches up with that. We can see that on Desmos as well. Our period is 2 pi. Okay. Where are the asymptotes? We've already described that up here with our domain. Asymptotes are at x equals pi over 2 plus pi k, where k is an element of the integers. All right, what's next? Cosecant. Okay. Now, I don't think we have to go through that same process that we just did for secant to come up with cosecant. Okay. Let's first think about the relationship between sine and cosine. Okay. The relationship between sine and cosine is they're just horizontal translations of each other of how far? Just pi over 2. Okay. Now, we know the cosecant is 1 over sine. Right? We know what 1 over cosine looks like, so 1 over sine would also just have to be a horizontal translation of the secant. So if I put the secant back up there, and then I graph the cosecant, we will notice that they are just horizontal translations of pi over 2. Okay? So let's get rid of that secant now. Let's throw up the graph of the sine, and we will see that just like the relationship between cosine and secant, the relationship between sine and cosecant is the same. They kind of come up here, kiss each other. Okay, go back down, meet up again down there. Okay. So let's see here. We should probably get this into our notes. I'll just take a picture of that. All right. So what is our domain? Okay, again, it's going to be most of the real numbers, just except infinitely many of them that are not. Okay, so what values are not in the domain of cosecant? Well, what do we have right there? What value is that at? Okay, what value is this? Notice there's a vertical asymptote at 0. Where's the next one happen? You know, it happens at pi. And why does that make sense? What is the sine of pi? The sine of pi is 0, and the reciprocal of 0 is undefined. So it happens at 0, pi. Next one happens at 2 pi. It happens every spot where the sine is equal to 0. So we will write this as except pi k, where k is an element of the integers. Its range is just like that of the secant. Its period is also going to remain 2 pi, and the asymptotes we already described where those are. Wow, this video is, sorry this video is getting long. It's just kind of fun to look at these. We have one more to go. Okay, we have cotangent. Okay, now we know tangent has a totally different graph than sine and cosine. Cotangent is totally different than the secant and cosecant. Let's just jump right to the graph here. Okay, there it is. Okay, you might be thinking that looks a lot like tangent. And it should make sense that it looks a lot like tangent. They're just kind of reversed here a little bit. Notice where the tangent is equal to 0. The cotangent is undefined. Okay. And it just kind of reverses, right? So if we take the reciprocal here of -2, that would be -1/2. It's closer. Okay. And the reciprocal here, that's going up to infinity, is going to be close to 0, and so on. So I'm going to actually pause this video quick. I'll write in the information for cotangent. All right, so make sure that you get this down. You take a look at the graph here when this video is going to end in about 10 seconds. Notice the vertical asymptotes are at 0 pi, 2 pi, 3 pi, wherever the sine, or wherever tangent is equal to 0. Thank you.